For our research question, we wanted to explore whether extracurricular activities in college have an effect on salary for engineering graduates. Our rationale behind this includes the following. Students, parents, school administrators all benefit from knowing what leads to students to the best outcomes possible. Also, according to Tony Wagner, director of Change Leadership Group at Harvard Graduate School of Education, says kids who have a significant involvement in extracurricular activity have a capacity for focus, self-discipline, and time management that I see lacking in kids who just went through school focused on their GPA. So we asked, does this lead them to making more money when in the actual workforce? Finally, we hope it will incite further discussion of the topic and lead to more thoughtful research. We used the Purdue Gallup data to analyze our research question. The Gallup report is a study of more than 30,000 college graduates across the U.S. After adjusting for missing info and narrowing to those who graduated with an engineering bachelor's degree, our sample included 63 individuals who had completed the survey fully.
After receiving the Purdue Gallup data, we focused our research on the individuals who graduated with a bachelor's degree in engineering, specifically engineering fields of civil, mechanical, electrical, computer, and industrial engineering. The data reaches back all the way from 1952 and continues until 2015. We used the demographics of gender and nationality as our control variables. We then organized the categorical variables of extracurricular activities into the following categories: Greek life, NCAA sports, intramurals, club and organization involvement, internships, leadership opportunity, and research, and then gave them a binary code of ones and zeros to tell us which individual were involved in which extracurricular. The salaries given to us were given in ranges instead of being a continuous variable, so we also gave these ranges a binary code, but the only range we found statistically significant enough to perform a regression was the range of $90,000 to $120,000 a year. Next, we used Minitab's binary logistic regression function with the majors, extracurriculars, and demographics as the categorical variables, graduation year as the continuous variable, and the salary range as the response variable. By interpreting p-values and odds ratios, Minitab's output told us a number of things. 1. That graduation year is a significant predictor of salary. 2. Compared to internships, leadership and research involvement have a 90% less chance of reaching the $90,000 to $120,000 salary range. 3. It is 160 times more likely to reach that salary range in computer engineering over civil engineering. And 4. It is 90% less likely to meet the salary range in mechanical engineering versus civil engineering. The graphs of our output told us that our data was normal.
From our findings, we found the following predictors have influence when determining salary: leadership, experience, research, mechanical engineering, and computer engineering. Since our R-squared value was just over 15%, there is still quite a large portion of our sample that is not accounted for. This leads us to believe that our model could be improved. Our assumption that everyone answered truthfully is a source of variation, since people could exaggerate or underestimate what their actual salary is and multiple other things. A large amount of the data points had to be omitted due to missing information. The way the data was formatted was not ideal when performing the regressions. For example, salary was reported in brackets and not an actual value. As stated before, this study impacts anybody who wants to know how to best increase their prospects of attaining higher pay in their career. We hope this analysis will provoke interest in the topic and eventually lead to further study of what actually makes job candidates more favorable to their employers.